Welcome to CATS Tutorials, and in this video I'll be covering practice problem 6.8. Now we're given a 1 millihenry inductor with the following function for its current, and we also find the terminal voltage as well as the energy stored in it. Okay, so let's just get some formulas out of the way so we can start. So for inductor, V is equals to L di over dt, and energy is equals to half L I squared. Okay, so these are the two formulas which we're going to find useful. And now we also find the voltage, which is simply given using this formula. So all we have to do is just to plug everything into this formula and this formula as well. And so let's continue. So for V, which is the first part, the voltage, we're going to say V is equal to L, which is 1 millihenry, so 1 times 10 to the minus 3, multiplied by the derivative of the current function, which is given to us as 20 cos 100t times 10 to the minus 3, right? So that is that. And so all we have to do basically is just to simplify this side, or to differentiate on this side, and then multiply everything out. So just familiarize yourself with derivatives and stuff like that. And so the derivative, of course, is sine. So also we have to apply something called, what is it called? This I forgot, I forgot what it's called, but basically you have to take this 100 out as well. So the result of this will be 20 multiplied by 100 multiplied by, now the derivative, of course, which is negative sine, 100t, and using the same units. And now all of that is going to be multiplied by everything which you had originally in your function. I'm just trying to remember what this is called. Is it called the interesting. Something that has to do with differentiating a function inside a function. Because as you can see, this is 100t, which is inside another function cos, right? So differentiating this by itself will give you this 100, which we took out. I just forgot what it's called, but doesn't really matter. As long as you do it correctly, you'll be fine. So that is that. And so let's multiply through. This is going to be 2000. Multiplying it with that is going to cancel out all the zeros. So all you're left with is just 2. And therefore, V is equal to negative 2 sine 100t millivolts. And the milli is from the 10 to the minus 3 over there. And the 1000 here is going to cancel out with this 10 to the minus 3. And that is why we have 2. And the negative is from the derivative. So that is that. We have the voltage, which is sorted. So we are done with that part. Next, we are going to compute the energy using this formula, which says W is equals to half L I squared. We are given an I in the question, we're given L as well. So all we have to do is just plug that into the formula. We have 1 millihenries, which is that in numerical form. And we have the current given to us as 20 cos 100t times 10 to the minus 3 squared. Now all we have to do is just square this and multiply through. So we have W is equals to 0.5 multiplied by, so this is 0.5, let's see, 0.5 from that point, multiply by 10 to the minus 3. And squaring this, we're going to have 40 cos squared 100t. And on this side, we are basically going to have, what are we going to have on this side? We are basically going to have, so what's going to happen to this? Let's try multiplying it by 2, which is going to become that. But then what is going to happen on this side, which is quite interesting. So if we multiply 40 by 0.5, we obviously get 20. And this 20 multiplied by this is the same as 20 divided by 1000, which is going to be equals to 0. That cancels out, which means this is going to be 0.2, right? It's 2%. No. Yes, it's 2%, so it should be 0.02. That should be the case, but no. The problem is here. The problem is here. 20 squared is 400. There is the problem. Good. And this is why you should always use a calculator. Now this video is unnecessarily long, and yeah. So 400 multiplied by 0.5 is 200, right? And that 200 divided by 10 by this, 1,000. You're going to have this, right? Cancel both of those. Then you're going to have 2 over 10, which is equal to 0.2. And therefore, your final answer will be 0.2 cos squared 100 microjoules. So that is all for this question. That is how you find the voltage and the energy.